Dear first prep, Assalamu alaikum wa rahmatullahi wa barakatuh. It's Mr. Ahmed Mahmoud with you today to introduce a new mathematics lesson. Today, inshallah, we have Geometry Unit 3, Lesson 8. The lesson is called Reflection. Okay, in the last lesson, we studied the reflection, rotation, and translation in general as a geometric transformation. But in this lesson, inshallah, we are going to study specific in the reflection, and we studied the properties of the reflection and how can we reflect the point by using the axis, x-axis or y-axis or the origin. Let's start the lesson. First, we are going to study how can we reflect a point by using x-axis. Okay, reflection on x-axis. Let we have a graph like this. This is x-axis and this is y-axis. Okay, for example, if we have a point A, its coordinates 3 and 2. 3 and go up to 2. This is a point A. What if I need to make a reflection, okay, and use x-axis as the axis of reflection or the mirror? Okay, it's clear that the point A will go down. Here the distance between A and the x-axis 2 units, so the image will be below x-axis also by 2 units here in this position, and its image here is called A dash, and A dash here opposite to 3 and go down to 2 to negative 2, A dash equals 3 and negative 2. By comparing between A and A dash, here A, its x is 3 and the A dash, its x also is 3. Y here is 2 and Y here is negative 2. Then there is a difference between the sign of Y and Y of A and y of A dash. So the rule of the reflection will be like this. If A equal x and y, so A dash equal what? Equal x and the negative y, like this, because x is the same and y change from 2 to negative 2. Okay, now what will happen if I need to make a reflection by using y-axis? Okay, here the distance between A and y-axis equal 3 units. So the image of A by using the axis y is 3 units after y here in this position like this, and I'm going to call it also A dash or A double dash, whatever, it's okay. Okay, here A dash by using the reflection on y-axis, here x or 3 becomes negative 3 and y, okay, still the same. Okay, so the rule of reflection of y-axis, if A equal x and y, so A dash equal negative A and negative x and y, also again negative 3 and 2. Okay, we change the sign of x from 3 to negative 3, and y still the same, here 2 and here also 2. Finally, okay, what if I need to compare between the reflection on x-axis and the reflection on y-axis? The reflection in x-axis change y, okay? The reflection in y-axis change x. Finally, what if I need to reflect A, okay, by using the origin point? We know that the origin point, this is its position. Okay, if I need to reflect A by using the origin point, okay, it comes from here to this position. Okay, the center of the reflection is the origin, so A will be changed from here to this position like this, and I'm going to call it A double dash or A dash, whatever. Here this point is -3 and -2. By looking carefully, A and A double dash, 3 becomes -3, 2 becomes -2. So if I need to make a reflection on the origin point, we change the sign of x and the sign of y like this. The reflection in the origin, A, x and y becomes -x and -y. We change the two coordinate axes. Remark, if the coordinate, if x is is y here is 0, 0 has no sign, so it doesn't change. Finally, reflection in x change y, reflection in y change x, reflection in the origin change x and y. It's a very easy lesson. Let's solve the first question. Example 1 with us. Complete the following table. We have here some points. Okay, I need its reflection in x-axis, reflection in y-axis, reflection in the origin point. Okay, this is x and this is y. Here x and y. In the x-axis it will be x and -y. In y-axis -x, +y. In the origin point -x, -y. Okay, 5 and 1. I'm going to change the color. 5 and 1 becomes, in x-axis becomes 5 and -1. In y-axis 5 and 1, -5 and +1. In the origin I'm going to change both of them. It will be -5, -1. Okay, another point, 2 and -3. In x-axis we change x, we change y, so it will be 2, +3. In y-axis we change x, so it will be -2, -3. In the origin I'm going to change x and y. It will be -2 and +3. Here -1 and 4. In x-axis we change y, so it will be -1 and -4. In y-axis we change x, so it will be +1, +4. In the origin we change both, so it will be +1 and -4, -2 and -6. In x-axis we change y, so it will be -2, +6. In y-axis we change x, so it will be +2, -6. In the origin we change both, so it will be +2, +6. Here in the origin we change, in x-axis we change y, 0, +1. In y-axis we change x, but x here is 0, so the point will be itself, 0 and -1. Okay, here reflection in the origin change x and y. X 0 doesn't change, and y and 1, -1 will be changed, so it will be 0 and +1. Here in x-axis we change y, but y 0 doesn't change, so 3 and 0 will be itself. Okay, and here y-axis we change x, so it will be -3 and 0. In the origin we change both, but 0 doesn't change, so change 3 only. It will be -3 and 0. 0, 0 in the x-axis is itself. In y-axis itself. in the origin itself. Okay, now another example. Here, draw on the square lattice. The square lattice is the coordinate axis, x-axis and y-axis. Okay. Draw A, B, C, then draw its image by reflection in x-axis and reflection in y-axis, reflection on the origin. Okay. So we are going to draw 4 triangles. The main triangle and its reflection in x, its reflection in y, and its reflection in the origin. Okay, first A, 3 and 2, 3 and 5 here, 6 and 1, 2 and 2. So I'm going to connect the triangle like this. A equal 3 and 5. This is A. 6 and 1 B. And finally 2 and 2 is C. Okay. Now I need the draw A dash B dash C dash, which the image of triangle ABC by reflection in x-axis. Okay. A dash equal reflection in x-axis change y, so it will be 3 negative 5. B dash 6 negative 1. C dash 2 negative 2. Okay, 3 and negative 5, 3 negative 5. This is A dash. Okay, 6 negative 1 here. B dash. And 2 negative 2. This is C dash. And then connect them, give me triangle A dash B dash C dash, the image of triangle ABC by reflection in x-axis. Okay. A double dash B double dash, reflection in y-axis. Okay. Here A double dash, we are going to change x, so it will be negative 3 5. B double dash negative 6 1. C double dash negative 2 2. Okay, negative 3 5 here. This is A double dash negative 6 1. B double dash negative 2 2. C double dash, and then connect them like this. Give me triangle A dash B dash C dash, image of triangle ABC by reflection in y-axis. Finally A triple dash B triple dash C triple dash, the image of ABC by reflection in the origin point. Okay, I'm going to put the point directly. A dash A triple dash will be negative 3 negative 5. Again negative 3 negative 5. Negative 3 negative 5 here. B double dash negative 6 negative 1. Negative 6 negative 1 here. C triple dash negative 2 negative 2 here. So it will be like this. This is A triple dash C triple dash B triple dash. Okay, let's solve the next question. Okay, now we are going to study a new concept called the axis of symmetry of geometric figure. Okay, by looking to this triangle. Okay, this is an isosceles triangle. Okay, the axis of symmetry, the axis of symmetry is a straight line at the middle like this. Divide the triangle into two congruent triangles. By another meaning, okay, in this term, here the axis divide the triangle into two triangles. Okay, by looking to the right triangle, the right triangle is a reflected image of the left triangle. Again, the right triangle is a reflected image of the left triangle, because the image of this point is this point, and the image of this point is itself, and the image of this point is itself. So the axis of symmetry, a new definition to the axis of symmetry. The axis of symmetry is a line reflect the shape to itself. The line that reflect the shape to itself, like this. Line that reflect the figure to itself and divide the figure into two congruent figures. You don't need to memorize the definition, you just need to understand the definition, and you need to memorize the number of axes of symmetry, because he asks you the number of axes of symmetry. Okay, first we have the scalene triangle. The scalene triangle hasn't axis of symmetry, so it has 0 axis of symmetry. The isosceles triangle has 1 axis of symmetry like this. The equilateral triangle has 3 axes of symmetry. Do you see? 3 axes of symmetry. When we said axis, 1 axis, we write it as with I. When we, and its plural is axes with E. So we have 3 axes of symmetry. Okay, another figures. Now the parallelogram has 0 axis of symmetry. The rectangle has 2 axes of symmetry. The rhombus has 2 axes of symmetry. The square has 4 axes of symmetry. 2, 3, 4. The circle has infinite number of axes of symmetry. 1, 2, 3, 4, 5, 6, 7, and so on. 8, and so on. I can draw infinite number of axes of symmetry. Okay, infinite number of axes of symmetry for the circle, to the circle. Okay, finally, the isosceles trapezium, it has only 1 axis of symmetry. But if the trapezium is not isosceles, isosceles means what? Isosceles means its 2 sides are equal. This is the isosceles trapezium, and its base angles are equal in measure. Okay, we are going to study in the next year, inshallah, but you need to memorize the number of axes of symmetry for the isosceles trapezium. It has 1 axis of symmetry. If the trapezium is not isosceles, so it hasn't axis of symmetry like the parallelogram. Okay. Example. On the lattice, lattice means coordinate axis, x-axis and y-axis. Determine the points A, B and C, then find the image of triangle ABC by reflection in x-axis, then mention if x-axis is an axis of symmetry of the triangle or not. Okay, here A equal 1, 2, 3, 1, 3, B 3, 1, C 0 and negative 1. Okay, here A 1, 3, B 3, 1, C 0, negative 1. Okay, the number here is negative 1 is y coordinate. So this point belongs to y-axis 0 and the negative 1 here on y-axis. Any point included 0 belong to axis, one of the 2 axes. Okay, here this is point 1, 3, point A, B, C. Okay, now I'm going to connect them like this. Now I'm going to write the images. A dash. In x-axis we change y, so it will be 1, negative 3. B dash 3 negative 1, C dash 0 positive 1. Okay, 1 negative 3, 1 go down to negative 3. This is A dash 3 negative 1, B dash 0 1, this is Y, so this point on Y axis 0 1. This is C dash. I'm going to connect them. Now X axis here is axis of symmetry for the two figures, but here he asked me find then mention if X axis is an axis of symmetry of triangle ABC. No, X axis is not an axis of symmetry of triangle ABC. Again, here triangle ABC, x-axis is not the axis of symmetry of triangle ABC. It's very clear. Okay, now another one. Properties of reflection. Properties of reflection. Let we have a rectangle ABCD and its image A dash, B dash, C dash, D dash. Okay, first we have some properties. The first property with us, reflection reserves length of segment. What does it mean, Mr. Ahmed? Here AD equal 3, A dash, B dash equal 3, BC equal 3, C dash, B dash equal 3, AB equal 5, A dash, B dash 5, CD equal 5, C dash, B dash equal 5. So the lengths of the segments in the rectangle ABCD doesn't change in the reflected image, so it reserves the length of segment. This is the first property. The second property, it reserves betweenness property. What does it mean, Mr. Ahmed? If we have a point here between A and B, so I'm calling it, for example, E. E dash appears here in this position. E between A and B. E dash between A dash and B dash. This is a betweenness property, so the reflection reserves the betweenness property. Okay, property number 3. Reflection reserves measures of angles. It clear? Angle A is right, E dash is right. Angle D equal D dash, C equal C dash, B equal B dash. So it reserves the measures of the angles. Okay, the reflection reserves the parallelism. What does it mean, Mr. Ahmed? AB parallel to CD, so C dash, D dash parallel to A dash, B dash, and so on. This is the properties. Of course, the properties comes in the complete. Okay, another example. Here in example 4, this example in the school book. Okay, number 1. Here we have ABC is an equilateral triangle. Here point B, here in this position. Okay, the axis of symmetry of triangle ABC. Because triangle ABC is equilateral, so it has 3 axes of symmetry. First AE, straight line, CD, and BF. Okay, question number 2. AB is a reflected image of AC. This is AB and this is AC. Okay, by reflection in what? Here B is a reflection of C by using E. and A is itself, so the axis of reflection is AE. I'm used the axis AE. Again, the axis AE reflect AB to AC, okay? Because B is the image of C by reflect in E. Okay. The reflected image of AB, okay, in BF. BF is an axis of symmetry, okay? The image of AF, okay. This is the axis of symmetry or the axis of reflection. The image of A is C, so I'm going to write C. The image of F, because F lie on the axis of symmetry, so its image is itself, so it is CF. Okay, a very important remark. If he gave you line segment, so its image will be also line segment. So the image of AF is CF. The reflection of CF on AE. AE is an axis of symmetry. The reflection of CF. CF, this is CF. Okay, C by reflect in AE, C its image is B, and F its image is D, so it is BD. The reflected image of triangle AMD, this triangle, by reflection in AE. Okay, here D its image is F, M itself, A itself, so the triangle will be AM. F is this triangle, AMF. The image of triangle AMB, this triangle, okay, this triangle AMB, its image on in AE is triangle AMC. Okay, it's very clear because B its image of C, M itself, A itself, so it will be AMC, triangle AMC. Another example, number 5. Complete the following. The image of 1, 3 by reflection in x-axis. X-axis change y, so it will be 1 and -3. The reflection of -2 and 5 by reflection on y-axis. Y change x, so it will be +2 and 5. The reflection of 2, -3 by the image of the point 2, -3 by reflection in what is 2 and 3. Okay, here the reflection which keep x is x-axis, or the reflection which change y is x-axis. Okay, the image of the point 0, 3 by reflection is itself. Okay, here itself because 0 doesn't change, so it is reflection in y-axis. If you can't memorize this one, so draw the point 0,3. This is the point 0,3. Okay, its image on y-axis is itself because this point belongs to y-axis. Finally, the point -3 and 2 by reflection in the origin change the two numbers. It will be +3 and -2. And this is the end of the lesson. I hope it was helpful for you. See you inshallah in the next video. Assalamu alaikum wa rahmatullahi wa barakatuh. Mr. Ahmed Mahmoud was with you.